This year, ARGO Team's rover is the most advanced robot we have ever made. We focused on identifying and fixing the previous year's mistakes, as well as further improving and developing our best systems. To make it possible, our members gave their best, making sure we are ready to compete in the URC. The rocker bogie suspension system makes it possible for the rover to ascend inclines of over 30 degrees and traverse difficult terrain. For this year's competition, we've designed a completely new mobility subsystem with 4 swivel wheels, able to rotate for 360 degrees. We've already completed testing the prototype and begun manufacturing the final product. The rover arms has 6 degrees of freedom and utilizes inverse kinematics to optimize its movements. It can lift objects weighing over 5 kilograms as well as perform precise movements required to complete the equipment service and mission. Furthermore, it can be equipped with 2 different grippers based on the upcoming task. It gives us more flexibility and adaptability, ensure we are using the best possible configuration. The rover is powered with a custom-made lithium iron phosphate battery pack hooked up to a custom-made PCB, which handles power distribution and is equipped with an external kill switch in case of emergency. This year, our electronic subteam members have adorned themselves, contributing to some of the biggest changes in the rover's design. They've designed and created several new PCBs, adding tons of new functions to the robot and making servicing and troubleshooting much easier. One of the new features are the PID controllers used to control the wheels. The custom-made control station gives the operators access to real-time feeds from 7 different cameras mounted on the rover. It aids the operator in grasping the situation, which, along with personalized graphical user interface, makes controlling the rover more intuitive. The software it uses was made from scratch by our programmers using C++ and Python. To compete in the autonomous navigation mission, we have developed a completely new autonomous navigation system. The rover uses its onboard cameras to look for AR tags, and after finding and recognizing the pattern, it executes the assigned algorithm. The status of the task is signalized by a corresponding LED. While moving towards the marker, the robot is constantly monitoring its API angles and corrects the path when they approach set thresholds. To handle all the data processing, we have equipped the rover with the NVIDIA Jetson TX2 running robot operating system. It's a big change from last year's design, and it has heavily impacted the robot's performance, improving processing speed as well as making debugging and troubleshooting much easier. Now, after building a strong foundation, we are working on implementing new solutions to achieve even better results. To excel in the science task and meet this year's requirements, the science team has created a completely new science module. The system is designed to determine the presence or absence of life using 3 different methods. It's made of 2 parts, the onboard laboratory and the rotary tool selector. The latter is equipped with 3 different instruments. The first, a portable high-quality, high-resolution microscope with 500 times magnification, allows us to analyze not only the sample but also the results of the other tests. The next one is a 3D printed soil collector able to collect and deliver the sample to the laboratory. Last but not least is a set of sensors, which includes temperature sensor, soil moisture sensor and pH sensor. They all together provide valuable data used to analyze the soil. The second part of the module is the onboard laboratory, used to perform various tests and experiments in situ to determine the presence of life. The delivered sample is evenly distributed to separate containers where it is tested using a biorate test, ion test and protein detection method. To see if the rover is ready to enter the competition, we've performed a set of tests. Communication was tested by measuring a signal strength and stability over various distances and during different weather. We've created software that analyzed collected data. It gave us important feedback we can use to fine-tune our equipment. We've put the robot suspension system under major stress by traversing difficult terrain, making sure it's ready for the URC harsh environment. On top of that, to train our operators, we have designed a mock lander, making it possible for them to become more adept in controlling the rover's arm movements and completing complex tasks requiring both focus and dexterity. After all the work we've done and experience we've gained from previous competitions, we are confident we are ready to participate in the URC and take on teams from all over the world.